Today, we're going to be continuing on our Python series, where we're going to look at two very important modules in Python, Numpy as well as Pandas. And essentially what we're going to do here is we're going to take a look at how we can use Numpy as well as Pandas and kind of look at how useful they can be, especially in terms of using specific methods. So Numpy and Pandas, again, are very, very important modules in Python, especially in the scope of data science, where again you can organize data and manipulate data. So again, today we'll be taking a look at the basics of them and how to use them. And with that being said, let's get into it. All right, so the first module we're going to take a look at is Numpy. And just in general with Numpy and Pandas, they are two modules that need to be imported. So first step we need to do is, of course, import Numpy. And we're going to say that since Numpy is kind of a long kind of word there, and essentially you will see Numpy imported as NP. So we will say import Numpy as NP. So import Numpy as NP. Now a really cool thing about Numpy is that we're essentially going to be creating an array with Numpy, or you can create an array with Numpy. And we can configure the values that we place in the array with certain attributes. So we'll be using, for example, as you can see, distinct methods like hstack.full, mean, not means. Now, here's what I mean in terms of creating our array with Numpy. And we'll be going over this first method, np.full, after that. So let's go here. So let's say that, and we'll place a variable name as well. So Fuchs is equal to np.array. And now an important distinction to make here. Of course, to create the array, you need to place brackets in here and then you place the values, for example, 50, 60, 70, just like a list. And simple as that. And then let's call Fuchs as well. So as you can see the output here, it gives you the output of which is an array, and then it gives you the values. Now, I want to be creating a two-dimensional array. How would that look like? So in order to make two-dimensional arrays, and even more than that, you can even make three-dimensional, four-dimensional, we need to place extra brackets here. And then, of course, place a comma, and then put your second set of values. So we can say 80, 60, 70, 80. So again, note the syntax here. So you saw here that first I just had one bracket, or a set of brackets, I should say, just like a list. And then since I wanted to create two-dimensional array, I had to use kind of these extra brackets. And that's just, again, a syntax kind of structure for NP. So if I do that, there you go. So you can see that we have exactly kind of two rows here, and they are essentially, it's essentially, again, a two-dimensional array kind of structure here. Now, I'm going to be showing you guys kind of a simple method in Python, and that is np.full. So let's just add a cell here, insert cell below. So I can say np.full, and then with the full method, essentially what you're going to do is that you're going to say how many times you want to repeat a value. So for example, let's say 5 is how many times you want to repeat the value. And then the second parameter we put in here is the value that we want to repeat it. So for example, let's say 10. So there you go. So you see here 10 is the value and it's repeated 5 times. So 1, 2, 3, 4, 5. And with the full method, it's a very simple method, but I think it is a method that you can use to kind of put certain data in and also repeat the data as many times as you want, or how many times you want that data to be placed or given as an output. That's just a simple method if you guys want to play around with. Now I'm going to be using showing you guys how to use a more useful method here, and that is RANDOM.RANDINT. And that is very useful to gain random integer values. And I think it's really an enhancement of the .full method, to be honest. So the .random.randint, it's basically an avenue to use the random module, but in the scope of NP, which is pretty cool. So let's say that np.random.randint, and then we say from this range, so 40 to 60, and then we can say that our third parameter will return, so let's say from this range, how many values? We can say 8. So here's the output, and I'll show you guys how that will look like. Okay, so you see here that we have 8 values. So you saw here I put 8 in the third parameter. So we have 8 values from the range 40 to 60, correct? Because we have 54, 59, 40, 52, so on, 56. So these are all values in the range of 40 to 60. But again, how many values do we have? We have 1, 2, 3, 4, 5, 6, 7, and 8. Again, a very intuitive method. I think it extends from .full, that we can have certain number of values in a specific range, in a set range. Now, in addition to that, another really cool method, or cool methods, are VStack and HStack. And I think that these methods, in terms of NP or NumPy, are great to use in order to organize data and structure our data. So let's say that, again, we had np.horizontalStack pass in our array, which is Fuchs. And then let's see how that will look like. And keep in mind that this method is HStack. And what this is saying is that it's going to horizontally stack these two sets of values. So again, let me show you the output. There you go. Before we used this method, that Fuchs was a 2-dimensional array, correct? But now with this HStack, we're basically combining these two sets of values, these kind of two arrays here, into one big kind of an array, one big array. And that's what we did. You saw here that 90, 50, 60, 70 is our first set of values, so 90, 50, 60, 70. And then the HStack will just combine 80, 60, 70, 80 in just in addition to this 90, 50, 60, 70 values. So we're essentially changing from a 2-dimensional array into a 1-dimensional array. But if I just use VStack, it should just be the same. There you go. Because vertical stack is what this method is. We're just going to stack these two sets of values on top of each other. But HStack, horizontal stack, will kind of combine these values into one dimension, into, again, one complete set of values. We also have statistical methods such as .mean, .standard deviation, so on, and that you can also explore more methods in terms of statistics, but we can use the array's name in order to carry out these methods. And these are methods that essentially, again, they kind of measure our data, and we can kind of organize our data after we get these values. So for example, Fuchs.mean will return, of course, the mean of all of these values, right? And then we also have standard deviation, which is denoted as STD. And then it gives you, of course, the standard deviation of the values. Now, another cool method, and I promise this is the last kind of sets of method I will go over for NumPy, is arange as well as .reshape. So arange is kind of another alternative method for random.randint, which was this one. It's kind of similar to it, but I will show you guys, of course, the output and how we can work with it. So arange is another NP method. So you saw here that with mean std, I used the name of the array that I put, which was Fuchs. But like, for example, random.randint, I use np, the module's name. So I will say np.arange from, let's say, 40 to 60, and it will give you all the values in this range. So 40, 41, all the way to 59. And remember that in terms of range, the last value is not included. It only goes up to, right? So this would be a total of 20 values, right? And you can see here that it is technically a 1-dimensional array, but we can actually modify this using the .reshape method. So if I say .reshape, and then I say that since it is 20 values in total, I can reshape it in a 10 by 2 array. So 10 rows and 2 columns. That is pretty neat. So you see here again, I have 10 rows of values and then 2 columns per value, per set of values, right? So 40, 41, 42, all the way down. You can also say 5 by 4, because in the end we want 20 values, right? 5 times 4 is 20, 10 times 2 was also 20. So you have again now 5 rows, 1, 2, 3, 4, 5, and 4 columns, 1, 2, 3, 4, to organize all your values there. Again, another cool method to kind of manipulate data, create data, and also organize data using the NP module. Now, with that being said, let's kind of shift into Pandas. So Pandas is essentially an enhancement of how we use NumPy. And I think it is more useful and more organized in terms of data and also manipulating data. So I like to think of NumPy kind of the foundation, and Pandas just kind of also enhances that, and we can use more methods to kind of retrieve data and also organize data. Methods that deal with those kind of aspects. Now, in order to make Pandas, or to make our array values in terms of Pandas, we will use the DataFrame attribute. And then in addition, I will show you guys methods such as .lock, .sortIndex, and so on. Okay, so Pandas, again, we will import Pandas, and then just like in NumPy, we will shorten the name of that module library, as we will essentially shorten the word into another kind of name. And Pandas is usually shortened as PD. So we will use that. And again, we will use .dataframe, right? So, and of course, in addition to placing a variable name, I will say cooks is equal to PD.dataframe of, let's put Fuchs in here. So Fuchs, and then let's call cooks and see how that will look like. Okay, so again, you saw here that with the .dataframe, I placed the Fuchs array. So from NumPy, there's a relationship between Pandas, because what you can do here is you can create the array from scratch using brackets, as I showed you in NumPy, or you can use the array you created from NumPy and place it into the .dataframe attribute in order to create the Pandas kind of enhanced array. And you can see here that the output is actually very neat. It is very organized, and it is kind of in like a data set, right? You can see here it shows you the index values of both the rows. So row 0 we have these values, row 1 we have these values, and also the columns are indexed, which is pretty neat. You can see here that 0, these are the columns, first column, second column, third column. Now another cool thing, another kind of minor thing you can also do here is that in order to change the index values of the rows, you can change it from an integer value to a kind of a name. So you can say mooks, and I don't know, you can say looks. So you saw here that I just changed the index 0 to mooks, and then I changed the row 1 to looks. So something very fun to do here, basically. Now, after that, some useful methods we can use for Pandas is the .lock and .ilock. And we can retrieve specific data values. So how we will use this is we will say, let's say cooks, we had cooks, correct? So cooks.lock of, and then with the .lock and .ilock methods, we will have to use the row values, so mooks and looks. So keep in mind that we will only use mooks and looks in terms of row values, right? So we will have to say mooks from looks. And then if you place a comma here, we can say that within these row values, we can get certain values from specific columns. So let me show you guys how that will work. So let's say, as an example, from column 1 to 2. There you go. So the .lock method, again, we have to specify the row values that we want. So mooks to looks. So we got both mooks and looks, right? And then after that, we can also specify the columns that we want returned in addition to the rows. So with rows mooks and looks, we wanted the values that are pertaining to column 1 as well as column 2, which we got out, right? Mook's at column 1 and 2 is 50, 60, and Luke's at column 1 and 2 is 60, 70. Now with the iloc method, essentially what we're going to do is that it's essentially using the integer values. So you saw here that I changed the names from 0 to 1, or I changed 0 to 1 into names, right? I said Mook's was at index 0 and Luke's was set to index 1. So still, technically Mook's is still 0 at index 0 and Luke's is still at index 1, right? So I can just say from 0 to 2, and I said 2 here because this is just not including. If you use integer values, if we're using integer values, it is like we're using range. So make sure that if you want to get index 1, the last row value, make sure that you have kind of an extra number in there, the next number, to get Luke's included, because this is saying only up to index 2. So after we do that, we will actually get the same output, and there you go. So you still see that Mook's we still got the columns from 1 to 2, and Luke's we still got the columns 1 to 2 as well. Now we can also use Pandas specific methods such as the .set option, and the .set option, I really like it because it can organize our data, and here's how. And again, it's a Pandas specific module, so we'll have to use PD. So PD.set option, and then I will explain this afterwards. So precision, comma 4. And then after I do that, I'm going to say cooks.describe. Okay, so what did I do here? So first of all, let me show you guys, or talk about, I should say, the cooks.describe method. The describe method will return everything, every data in terms of the mean, the standard deviation count. The .describe method gives you a statistical overview of all your data values. So again, you can see, for example, we have the mean, we have the standard deviation, the interquartile ranges as well, which is really neat. So the cooks.describe method will kind of show you guys a statistical overview. And what I did with this set option method was that I was altering the precision. So essentially, I'm saying that how many values of decimal places we want. So for example, I said 4, right? So we have 1, 2, 3, 4. Yes, that's 4 decimal places. I can say I want more precision. I want more decimal values. So I can say 6. There you go. So you see here, especially in terms of standard deviation, we're getting more exact or more values. So you see here 1, 2, 3, 4, 5, 6 decimal places. We have more exact kind of values represented here. So the .set option essentially alters the precision of values in terms of how many decimal places you want. And the describe method essentially gives you an overview of all of the data you have, from mean, standard deviation, the interquartile ranges, and so on. Alright, so you can see here that with Numpy and Pandas, there's a lot of methods that we can use to kind of organize data and use data, right? But again, these were the basics of both the modules. But again, I wanted to show you guys how we can use them in order to kind of manipulate and use data, and also to retrieve data. And so this can be really, really useful in the scope, especially of data science, and to again work with certain data values. And with that being said, guys, thank you so much for watching. I hope you enjoyed this video, found this helpful, and learned something new about Numpy and Pandas. So with that being said, thank you so much again for watching, and I will see you in the next video.